We all know about the various measures of central tendency. We find a measure of central tendency to reduce a given set of data to a single value by which the whole set of data can be represented. There are 5 such measures which are quite common in use. They are arithmetic mean, median, mode, geometric mean, and harmonic mean. All these 5 measures are very important and are made for different situations. People often get confused as to which out of these 5 measures should be used in a given situation. The selection of an appropriate measure of central tendency is very important and should be done very carefully. Arithmetic mean, which is commonly known as average, is the most popularly known measure of central tendency. It possesses many important properties of an ideal measure. It depends upon all the values and is easy to calculate. It is defined as the sum of observations divided by the number of observations. It is amenable to algebraic treatment and is least affected by sampling fluctuation. Its power and its reliability can be well judged by the Elijah Wright's remark that while nothing is more uncertain than a single life, nothing is more certain than the average duration of 1,000 lives. But the arithmetic mean has one main disadvantage. It is particularly susceptible to the influence of extremely small or extremely large values. That is, the values which are unusual compared to the rest of values. For example, the arithmetic mean of 5 values 15, 10, 22, 18 and 12 is 15.4. Now let us add one large value, say 2200. Now the arithmetic mean of the set of 6 values 15, 10, 22, 18, 12 and 2200 each 379.5. The arithmetic mean has definitely gone very high due to a single comparatively large value. Out of 6 values, 5 values are more or less at the same tune. And due to one value, the arithmetic mean has gone so high. The high value has stretched the value of arithmetic mean to the right side. And so, in this case, the value of the arithmetic mean does not seem to be the true representative of the given set of 6 values. Median is the value that divides a given set of observations in two equal parts. 50% of observations being less than median and 15% of observations being more than median. Like arithmetic mean, it is also easy to calculate and easy to understand. One of the chief characteristics of median, which is different from arithmetic mean, is that it is not affected by either extremely large values or extremely small values. For example, the median of 15, 10, 22, 18, and 12 is 15. But if the largest value 22 is replaced by any other extremely large value, say 2200, then also median remains the same. Similarly, if the smallest value 10 is replaced by any other extremely small value, the median would not change. Mode is the value which occurs most frequently in a set of observations around which the other values of the set cluster densely. In other words, it can be said that mode is that value of a variable which is predominant. Geometric mean is another measure of central tendency. Geometric mean of n observations is defined as the nth root of the product of all the n observations. It is not as much known as arithmetic mean, median, and mode due to difficulty in its calculation by non-mathematical persons. Harmonic mean of a number of observations is the reciprocal of the arithmetic mean of reciprocals of the observations. For example, the harmonic mean of 5, 10, and 20 is 8.56. Harmonic mean gives greater importance to small observations. It is preferred in those cases where small observations are to be given more weightage. Like geometric mean, it is also not easy for non-mathematical persons to understand and to calculate. Defining all these measures is one aspect of our knowledge. Another aspect is the applications of these measures. What is more important is to know that which measures should be used in which situation. If we use an inappropriate measure in a situation, it may give us a picture far from reality. Now we would discuss the selection of appropriate measure of central tendency in particular situations. Let us take one example. Suppose we are interested in knowing the average monthly income of the families living in some area. For our convenience, suppose there are only 10 families living in that area, of which 9 families have their monthly income as rupees 2500, rupees 1800, rupees 2100, rupees 3000, rupees 1600, rupees 1900, rupees 1750, rupees 1600, rupees 1950, and one family, the 10th family, is a very rich family having its monthly income of rupees 3 lakh. The average monthly income of all the 10 families taken together is thus rupees 31,820 per family. Now the question is, can it be the true representative value of the monthly income of the families living in that area? How it can be? Where 9 of 10 families have no income more than rupees 3,000. Here, the value of arithmetic mean gives a false picture of the income of that area. It has gone up so high just because of one family having very high income in comparison to the incomes of other families. Then, what should be the appropriate measure of central tendency in such a situation? We have to find out here such a measure which does not give importance to this extremely high income, and this measure is median. In this case, the median income of the families is rupees 1925, which seems to be a true representative of the income of the families in that area. So, whenever we have not to give equal importance to extremely high or extremely low values, we prefer median to arithmetic mean. In most of the cases, whenever there is tussle between management groups and labor unions over the demand for increase in the existing wages of the workers, the management group often refers to the arithmetic mean of the wages very cleverly to impress the trade unions. The arithmetic mean of the wages taken into account the wages of all the employees, even of those big officials who are very highly paid, and this results in a very high average. Suppose that in a company there are 50 workers and their average, that is arithmetic mean of the wages, is rupees 21,000 per month, and the median wage is rupees 21,500. And suppose that in addition to these workers, there are three management executives in the same company having their average salary of rupees 2,64,000 per month. Clearly, the average wage would come out to be rupees 34,755. Only due to the three high figures, the average wage of the workers has increased by more than 65%. Three outliers here have radically altered the picture, rendering the term average deceptive of the real situation. The trade union people in such cases refer to median wage and expose the management for their wrong arguments, saying that 50% of the workers are having their wages less than rupees 21,500. In this way, the management side generally tries to take undue advantages of the arithmetic mean by selecting an unsuitable measure of central tendency. Though averages are generally used to compare two or more than two groups, the averages alone do not give any further inner details of the groups. If the average wage of the employees of a company, say company A, is rupees 22,000 per month, and the average wage of the employees of another company, say company B, is rupees 26,000 per month, then it may be said that the company B is better off than the company A so far wages are concerned. But from these average wages alone, one cannot have any idea about the disparities in the wage structure of the employees of the two companies. These disparities may be measured by calculating range or variance or any other measure. Thus, an average with some measure of variability provides information of some more practical value. Many people only calculate average, which may be deceptive. Arithmetic mean is always dragged in the direction of the skewness in data. In such situations, median is generally considered to be the most, or better to say, to be the best representative of the central location of the data. The more skewed the distribution, the greater difference between the mean and median. And in such cases, greater emphasis should be placed on using the median as opposed to arithmetic mean. People often do not know it and do wrong selections of the measures of central tendency. Mode is a peculiar average and is used in typical situations. There may be situations where only mode would be the appropriate average and the selection of other measures may be disastrous. Let us try to understand with the help of one example. Suppose you have been made the regional manager of the Liberty Shoe Company, and the day you join, your advice is sought for a single size of shoe to be manufactured during the current week. On your inquiry, you are told that the sizes of shoes range from 1 to 11. If you decide to find the arithmetic mean of the sizes, which is 6, and order for the shoes of size 6 to be manufactured during that week, then it would be the most idiotic decision of yours. What would be the result in this case? There would be large number of shoes of size 6 in the Liberty showrooms with very few purchasers, resulting a big loss to the company. Had you inquired about the size of shoe having the highest demand in the market, and had you ordered for manufacturing of that size only, the company would have been in profit. In other words, had you selected mode instead of arithmetic mean, the situation would have been different. Arithmetic mean, no doubt, is a very good measure. But there may arise situations where mode is preferred to it. It is used in finding average size of ready-made garments, average denomination of postal stamps, etc., etc. I will tell you one more point. Very often in our daily conversations, we use the word average, referring unknowingly to mode. For example, when we say that an average Indian is peace loving, here by average we mean that most of the Indians are peace loving. Here average refers to mode. Geometric mean is preferred in those cases where observations are supposed to appear in geometric progression, such as when to find the average population growth rate, average rate of interest, etc. We find geometric mean. Common people generally do not find themselves able to differentiate as to in which situation arithmetic mean and in which situation geometric mean should be calculated. They find arithmetic mean in those situations also where geometric mean is more appropriate. Harmonic mean is usually used in the situations when average rate or rate of change needs to be calculated. But there may be the situations where this average can more appropriately be given by arithmetic mean. And this makes difficulty in deciding as to when to calculate arithmetic mean and when to calculate harmonic mean for getting the correct average rate. Very often people commit mistakes in such cases, and thus statistics is misused. So whenever we have to find the average of rates, both arithmetic mean and harmonic mean may be the appropriate measures of central tendency. In some situations, in finding the average rate, arithmetic mean is appropriate, but for some situations, for finding the same average rate, harmonic mean is more appropriate. Very often people commit mistakes. They fail to find, they fail to decide that in what situation arithmetic mean will give the average rate and in what situation harmonic mean will give the average rate. I will like to suggest a simple method to you to remove this confusion in the selection of arithmetic mean and harmonic mean in case of rates, when the observations are regarding rates. This method would itself find out the appropriate mean, and it is not required to take any strain in deciding as to which one of the two means, arithmetic and harmonic, would be the appropriate mean in a given situation. Very simple method. Let us take one example. Suppose you drive a car for 20 kilometers at the speed of 50 kilometers per hour, and the next 30 kilometers at the speed of 60 kilometers per hour. The average speed of your journey would clearly be total distance covered divided by total time taken. Distance would be in the numerator, time would be in the denominator. Because here, speed we generally express as distance per unit time, kilometer per hour. So, the average speed of the journey would be total distance covered divided by total time taken, which would be in this example 20 plus 30. This is the total distance covered divided by 20 by 50. This is the time taken to cover 20 kilometers at the speed of 50 kilometers per hour. So 20 by 50 plus 30 by 60. 30 by 60 is the time to cover 30 kilometers at the speed of 60 kilometers per hour. So 20 by 50 plus 30 by 60, this is the total time taken. And so this would be equal to 55.5 kilometer per hour. This is the average speed. But what is this? This is the weighted harmonic mean of the two speeds, 50 kilometer per hour and 60 kilometer per hour. Now let us change our problem. Now if you drive a car for 2 hours at the speed of 50 kilometer per hour, and the next 3 hours at the speed of 60 kilometer per hour, then using the same formula means total distance covered divided by total time taken. So using this formula, the average speed in this case would be 2 into 50 plus 3 into 60. This is the total distance covered. Divided by 5. This is the total time taken. This average is equal to 56 km per hour. But here, this 56 km per hour is the weighted arithmetic mean of the two speeds, 50 km per hour and 60 km per hour. So automatically, you will get arithmetic mean if it is appropriate measure, or harmonic mean if it is appropriate measure, by using this technique. This technique can be applied whenever average rate is to be computed. In case of calculating average price, one can use the formula total amount spent divided by total quantity purchased. Because price we always denote as rupees per unit quantity. Rupees is in the numerator, quantity is in the denominator. So total amount spent is in the numerator and total quantity purchased is in the denominator. So in all such cases where we have to find the average rate, we can use this technique without giving any strain to our mind, whether to find arithmetic mean or to find harmonic mean. Automatically, it will come out to be arithmetic mean and harmonic mean. Though averages represent the given sets of whole data, they often mask the underlying distributions. And so dealing in averages, it's sometimes risky. I remember a Bhojpuri proverb in this context. The proverb is, लेखा जोखा था है, लइका डूबल का है. Which means that if all the calculations were correct, then why the bridegroom drowned in the river? लेखा जोखा था है, लइका डूबल का है. There is a story behind this proverb, which goes like this. There was one Bharat party, that is marriage party, going from the groom's village to the bride's village for performing the marriage rituals. On the way, there was a river without any bridge over it. A small boat was there which could accommodate hardly 5-6 persons at a time. It would have taken much time for the whole party, consisting of 50-60 persons, to cross the river by that single small boat. It had already become late. The sun was to set, and the Bharat party had still to cover a distance of 2-3 kilometers ahead. Nobody had any idea about the depth of the river. Had it been known that there was not much deep water, they could have crossed the river. One young boy in the marriage party who had read a little statistics claimed to estimate the depth of river. He sat in the boat, take some measurements of the depth of water at various points along the river, and then reaching on the opposite side of the river, calculated the average of each measurements. Here he calculated arithmetic mean. The arithmetic mean came out very small, and so he shouted with joy from there. It's only knee-deep waters. Let us cross the river. The marriage party crossed, and all, including the groom, drowned into the river. The young boy, who had read a little statistics, was surprised at how could it happen when there is no error in the calculation. The river can be very shallow, mere inches for long stretches, but it might transform into a raging torrent that is 10-12 feet deep in the middle, in which case one could easily drown. So one should try to work out the underlying distribution. If a single anomaly has almost no influence on the set, then the concept of average is worthwhile. However, when extreme cases dominate, one should discount the term average. Sometimes messages containing statistics are framed purposefully in such a way that the human psychology to react to such messages can easily be exploited. It mostly happens in the business world. Thank you. Thank you very much.